This video will demonstrate the steps for the gravimetric analysis of phosphorus in a common all-purpose plant food. Our goal is to use this analysis to assess the accuracy of a reported value of phosphorus in this plant food. This diagram provides an overview of the experimental approach. A defined mass of plant food containing P2O5, diphosphorus pentoxide, is dissolved in water, which essentially results in the aqueous hydrogen phosphate anion. This anion reacts with an excess of aqueous magnesium plus 2 from 10% magnesium sulfate and a slight excess of aqueous ammonia to produce the magnesium ammonium phosphate hexahydrate precipitate. This precipitate is collected by vacuum filtration, dried and weighed. From the mass of magnesium ammonium phosphate hexahydrate and the stoichiometric mole ratios in the balanced equations and chemical formulas, the mass of diphosphorus pentoxide in the original food sample can be determined. We start our experiment by precisely weighing 0.5 grams of the plant food with an analytical balance. The brand of plant food used in this experiment is called plant prod and has a fertilizer composition of 10, 52, 10. Of course, it is the number 52 which is of interest to us, as it represents the percent mass of diphosphorus pentoxide in the plant food. The plant food is then dissolved in about 20 ml of deionized water. While some brands of plant food may contain some insoluble material and therefore require a filtration step, it has been our experience that the plant prod brand is highly soluble and produces a homogeneous solution. As shown in this diagram, when diphosphorus pentoxide, our compound of interest, dissolves in water, it produces several aqueous products, from phosphoric acid to phosphate. These products are in equilibrium, and their relative concentrations depend on the pH. During the precipitation step, the solution will be made slightly basic, and the hydrogen phosphate ion, the anion required in the precipitation, will dominate. To ensure a complete precipitation of the hydrogen phosphate ion, an excess of magnesium cation is added. The volume of 10% magnesium sulfate required can be determined by a quick calculation, as described in step 3 of the procedure. Assume, for instance, that exactly 0.5000 grams of plant food is measured.
Multiply this by 0.052, which gives the mass of diphosphorus pentoxide, which is then multiplied by 5 mL per 0.1 gram to give the volume of 10% magnesium sulfate required.
In the next step, a slight excess of 1.5 molar ammonium hydroxide is added. The ammonium ion is obviously involved in the chemical formula for the precipitate, and the hydroxide ion will produce the appropriate pH so that the hydrogen phosphate ion predominates. To ensure that we add only a slight excess of 1.5 molar ammonium hydroxide, a few drops of the phenolphthalein indicator are added to the solution. The ammonium hydroxide is added only to the point when the indicator turns a faint pink color, which will look purple given the blue background, which indicates that the solution is slightly basic. It takes several additions of the ammonium hydroxide, with frequent mixing with the stir rod to achieve the appropriate pink-purple color. You may be wondering why it is important to add only a slight excess of ammonium hydroxide. Recall that this chemical is not only the source of ammonium ions, but also hydroxide ions. Recall also that we have an excess of magnesium ions. If we add too much ammonium hydroxide, we risk that a secondary precipitation reaction will occur in addition to the desired precipitation reaction. It is useful to reflect on how this experimental error would impact our estimation of phosphorus in the plant food. We will wait at least 15 minutes for the precipitation reaction to be complete. But in the meantime, we can weigh a sintered glass crucible, which will be used in the next filtration step. A glass crucible has a very small pore size, so that most of the precipitate will be collected. Further, unlike a filter paper, the sintered glass is resistant to damage from corrosive materials like ammonium hydroxide. In the next step, a vacuum filtration is set up, and the precipitate is quantitatively transferred to the crucible. Several low-volume washes with deionized water can assist with the transfer.
And finally, the dried crucible and the precipitate are weighed.